Hello, everyone. No fun background today. I'm just home in my home office, which is my son's old room. He was a Patriots fan, thus the red and blue painting on the wall. But anyway, to begin in this segment, I'm really disappointed to have to be doing this virtually because this was something I loved having this discussion in class. People would get very animated and very passionate about this discussion. So what we're considering is, let's suppose your score on a test was an 85.63. All right, so you divide on your calculator and that's what you get. All right, and suppose I accidentally, when I entered it on Canvas, suppose I put in an 84.63. Okay, you'd all complain, right? There's probably not really, once in a while there'll be one person who might be like, I wouldn't care, right? I'm like, wow, then you're really willing to be very general about your grades. Most people would object to this. Okay, so if I were to then, you'd all care about a point. So then I start asking, well, what if instead, I shorted you by a half a point, right? Let's suppose, wait, actually that should be an 85.1, right? I've just shorted you by half a point, right? Who would complain, right? And so quite a few of you would say, well, this rounds up to an 86, this doesn't. So, a half a point, that's a reasonably big deal, right? And so then I start saying, well, then what if I, what if instead of a half a point, what if I just shortchanged you here by a 1/10 of a point, right? Who's going to email me and say, excuse me, Mrs. Harris, I don't mean to bother you, but listen, I had an 85.6, you gave me an 85.5. Right? Are people going to complain? And so I love having this question in class because there's always that one person who is like, I need all the points I can get, and I will email you and ask you to adjust my grade by 1/10. Okay, so then I zone in on that person and I pick on them. Okay, so that's fun to pick on someone. But then I start asking them, okay, well, what about this? So let's see, your grade is 85.63. What if I gave you an 85.59? Are you still upset? And then they start, I guess, maybe, right? And so then if they say, yes, I'm still upset, then I say, okay, what about an 85.627, right? Are you still going to complain to me? And usually by this point, people are like, no, I would not complain if that were the case. All right. So look at these two scores. Okay. And if I were in elementary school where they make the students do like the greater than, the less than, or the equal to, right? No one's going to put an equal to between these two. They're not the same grade. But how many of you want to say, that is the same grade, right? 85.63, 85.627, that's the same thing, right? And by this point, people are nodding their heads like, yeah, that is the same grade, okay? So sometimes in math, we run into a situation where we say, well, the answer is 2.9, and then I have like 12 nines, and then a 13th 9. And, I don't want to write 2 point with all those nines. Can't I just call it 3? Like, aren't we close enough to 3, right? And so again, how many of you, which I wish you could raise your hand, but I bet if we were in class and I said to you, how many of you, when you see 2.9 with 13 nines sitting there, how many of you want to just say, yep, it's 3? How many of you are good with that? Right? And pretty much everyone will raise their hand and say, yeah, I'm good with that. Now, there might be situations where your you know, some scientists have to be extremely precise, right? So those scientists might say, wait a minute, 2.9 with 13 nines is not 3. You know, like if you were working in space travel or something like that, where the slightest change in adjustment, right, when you send something out to space could lead to miles and miles of inaccuracy, right? So those people might want to say, wait a minute, 2 point and then a 9 with 13 zeros, that is not 3. All right, but for most of us, we want to say, yes, for heaven's sakes, that's just 3. Okay, so hold that thought a minute. And I encourage you to have Desmos open. I like Desmos. I think it's actually a little bit more user-friendly than your TI 83s and 84s. Okay, so come over here on Desmos, and I started with this function. Okay, so far we've looked at some parent functions like x squared, radical x, things like that. We're going to look at these functions, which are called rational functions. A rational function, and I'll formally give this definition later, but it is the ratio of 2 polynomials. Now, what's a polynomial, right? And I'll give that definition a little bit later. But anyway, actually, before I go any further with that, though, let's do this. Clear all my drawings. Okay, so on that page, I had y equals, what did I have? X minus 1 over x plus 2. So if I asked you about the domain, what can I input into this function? Okay, domain is input. And when I gave you the definition of domain, I said there's really only 2 things we have to worry about. Okay, I cannot input a value for x that would give me a negative under the radical. I also cannot input a value of x that would give me a 0 in the denominator. Okay, well, I do have a denominator that I have to worry about right here at -2, right? I cannot input a -2. So I'm going to put an open circle here on the number line, but then I'm going to shade the whole rest of the number line. It's a little hard to shade nicely with this little pencil, okay? But anyway, so I can input radicals, fractions. I mean, it wouldn't be fun to input fractions and figure it out, but mathematically that's allowed. And so I would write my domain to be -infinity. I can see that on the number line. I can start all the way down here at like -200 billion. I could input that if I wanted to. I get up to -2, but I can't include it, right? And then I can start up again, but not include -2. So here's what I want to talk about, is how close can I get to -2, right? X can't be -2, but how close could I get? Okay, could X be -1.9, right? Sure, okay. Could X be -0.999, right? Would that work? So let's go look at this on the graph. Then we've looked at it algebraically. Let's look at it graphically. So on my shared screen, back to this. So look at this graph and look at what's happening here. Here I am at -2 right here. It might look like, and what I like about Desmos is you can like zoom in and out so efficiently, right? On your graphing calculator, you have to go in, set the window, all that. Although I guess you do have a zoom in and zoom out key, but I just find this easier to just, you know, click here and grab and go back and forth so quickly. So anyway, if you're really zoomed way out, it might look like at -2 that the function has, you know, a value, right? Because it looks like you've got this vertical line here. but that's just because you are just zoomed in too much, okay? If I zoomed way out and I'm looking at -2, the function, right, there's no input at -2. So this is another thing I like, is I can like scroll down. So see how this line is like -2 is right here. See how this line is, it's very close to -2, but it never touches -2. Okay, so look at me scrolling down and down and down. Eventually, just there's not enough difference in the computer screen and the line, so it starts to look like I'm touching here at x equals -2, but I'm not. Okay, so how close am I getting though? I mean, we can see that I'm getting very, very, very close to -2. Now, because I don't ever touch -2, if I were to draw this on my screen, okay, so if I go back to stop share and I go back to this screen share and I were to draw it here, what's happening there is I have what's known as a vertical asymptote line. So I do this, and hang on here, let me try to remember. It went this way, right? Oh, that's not a very good drawing, but what happens is my function gets closer and closer and closer to that value, right? The x can get very, very, very close to where that asymptote line is, but the functional values, as I get closer and closer, the functional values get very large or very, very large in a negative way, which I should be saying very small technically, but large absolute value. Okay, so I would have a vertical asymptote line at that point. So when we draw those on our paper, we typically draw them with a vertical line. If you're graphing on a TI-83 or 84, the older versions, I bet you guys have the more updated versions that don't have this, but sometimes the older versions, and this was your calculator not being smart enough, it would actually connect the very last point it plotted here to the very last point it plotted here. And so sometimes on the calculator, it would look like there's a straight vertical line, okay? And you should recognize, first of all, a vertical line could never be part of a function because obviously it would fail the vertical line test, right? This is not a function. And so sometimes what was shown on the calculator screen was misleading. You probably see the exact same thing I see on the screen here in Desmos, where there's just nothing at x equals -2. Okay, there's nothing there. So anyway, I'm going to do this. I'm going to come up to this wheel. This makes a copy. Okay, then from the copy, I'm going to convert to a table. All right, and it's telling me that when x is -2, my function is undefined. Okay, but I want to know how close to -2 could I get? Okay, could I be at -2.01? All right, that's on the left-hand side of 2. Could I have an input of like -1.99? That's on the right-hand side of 2. Okay, and if I'm very close to 2, I get an output, right? So how close to 2 can I get? Okay, and you know, could I keep adding zeros here and getting functional values? And as we can see, these functional values get very large, right? I can see that looking at the graph, okay? Or get very large, have very large absolute value, meaning they're actually getting very small because they're large. I shouldn't say large negative values, but you know what I mean. All right, and so I can just keep on getting closer and closer and closer to -2, right? And so look how many 9s I'm adding here, or look how many zeros I added up above. And now the calculator, now it's actually starting to round off. That's why I said it says undefined, is it's finally, right, when I get to this many 9s, finally my computer can't handle that many more 9s and says, oh, for heaven's sakes, we need to just round it off to -2, right? But a lot of that is what we do. We say, oh my goodness, -1.999999999999999999999. Well, how about we just call that 2? Okay, and so when I say how close can x be to 2, the answer to that is very, 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 very close. Okay, now you're probably not going to be surprised if I tell you that the term very, 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 very close is not a precise mathematical term. Okay, so we need a mathematical term to say that I can get very, 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 very close. Okay, so that I don't have to keep saying all those varies. Okay, so let's look at together. This is actually an example from the handout on the intercepts, holes, and asymptote line handout. All right, and so we are going to look at the graph of x squared minus 9 over x minus 3. Now, if I went to the other page, okay, so I stopped share and I went back to my whiteboard and I asked you, you know, what is the domain here? What is it that I cannot input into this function? All right, there's no radical. Don't have to worry about x under the, anything under the radical. However, I do have to worry about a 0 in the denominator. Okay, so x can't be 3. All right, so if I drew my number line, here's 3, x can't be 3, I can be anything else, right? So then let's write this in interval notation. I can be anything, you know, I can be negative 200 billion. I could input that if I wanted to. Can't input 3. But again, how close to 3 can I get, right? I could input 2.9999999999999, right? So again, I can get very, 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 very close to 3. All right, and so we're going to look at that a little bit more carefully on table. Okay. And then we're going to define some things. All right, so this is another rational function. And in the last example, when we were, the value that we could not input, there was a vertical asymptote line at that value. So interesting that this time, let's look at the graph. First of all, the graph just looks like a straight line. And if I go to x equals 3, which is halfway between 2 and 3, it sure looks like I have a point, right? It sure looks like if I input 3, I output 6, right? So why is there not an asymptote line there like there was in the last example? So let's examine this on table. Okay, so I duplicated it and then I clicked table. And I'm mostly interested in what's happening when, you know, like this is all nice that they're showing, you know, -2, -1, and so on. I'm mostly interested in what's going on at 3. Right, and the function's undefined at 3. Okay, if I put 2 here and a 4 here, right, and you looked at this, you said, well, yeah, at 2 the functional value is 5. 3, the functional value is undefined. It doesn't look undefined to me, right? At 4, the functional value is 7. So yeah, this should be a 6, right? Well, what I can't see on the screen, because it would literally only be missing 1 pixel, okay? So it doesn't show up on the screen, but there would be a hole there at 3, all right? This function would have a hole at the point 3, 6. But to examine that a little bit more carefully, let's get closer to 3. All right, let me get close from the left of 3 on the number line. Let me look to the right of 3 on the number line. right? And let me look for evidence that if I'm very close to 3, the functional value is very close to 6. Now, can I get 6 as an output from my function? Because if I said, what's the range, looking at this, you know, you'd feel like, okay, the range is all reals. Any real number you gave me, I could, you know, I could find an X value that would output that. So that looks like the range is all reals, okay? But can I output 6? All right, so let's see if I can get 6 as an output, right? The closer and closer I get to 3, the closer and closer I get to 6. Now, eventually, my computer's going to round these values off. Eventually, my computer's going to say, okay, for heaven's sake, you put in all these zeros, then a 1, that's just 3. And then they're going to give me an output of just 6. See, right there, it just rounded off. So that's actually not true. That is the computer rounding. Your calculator will round. What is happening is that I never actually get a functional value of 6. Now, how close to 6 can I get? Because if I kept adding more zeros here, I should just add more zeros here. And if I kept adding more 9s here, so if I add like 59s here, I should have 59s over here, okay? But my screen is just, it's not gonna hold that many characters. So again, I will never get an output of 3, or 6, I mean. I can never actually step on 3, but I can get very, 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 very close to 3. I will never get an output of 6, but I can get very, 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 very close to 6, okay? So what I'm seeing here is that if I let X be very, 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 very close to 3, then the output is very, 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 very close to 6, okay? I need a much better and I need a more mathematical way to say that. So let's take a break right now, and then in the next segment, I will give you the mathematical term for very, 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 very close.